Welcome to our March 2025 Data Science Lab monthly seminar. This is going to be a joint seminar. I'm going to do the first part, and Josh is going to do the second part. And this is a update of a seminar we gave last April. At that point, we called this ChatGPT, or large language models as your research assistant. We've had so much interest on this topic that we've been asked to give an update. Obviously, a lot has changed in the Gen AI and large language model space in a year. And so if you're interested, you can go back out to our recorded seminars and take a look at this from last year. I guess maybe another reference, last year's seminar was maybe a little bit more focused on broad strokes functionality. Today, I've tried to focus a little bit more on specific tools, although we still don't get very deep into too many of these tools. And then first, I do always give a sort of preamble on these large language model conversations. I just want to state that even though we're presenting on these, even though the data science lab uses these tools pretty frequently, I still consider these tools. I think you have to be careful not to consider these solutions to replace, big parts of research wholesale. I think you have to use them really carefully. And so I do advocate, while these are useful tools, to think about them carefully and to think about, the portions of your work where you can use them and use them successfully, and without doing anything that could be controversial, either locally or in the larger scientific community. And so with that being said, UNC does have some amount of guidance on this topic. So coming out of the provost's office, there are some guidelines for a variety of different communities. There are some guidelines, I think, sort of more generally for the UNC community. There are guidelines specifically for the research community, as well as for students and teaching. And so if you're trying to get a sense for what UNC is thinking about this, you can go out and look at these guidelines on the provost's various web pages. And then additionally, there is guidance at this point from almost every journal that you would be submitting to. And for the most part, these are pretty extensive. So, regardless of how you are using these tools, whether it's, as part of the research process itself, or whether you're using it as part of review or actually, contributing to the writing, pretty much every journal is going to have fairly strict guidelines on how you identify that, maybe even on what the use is. And so in addition to, local, you really do need to be in tune with these pieces of larger scientific community, especially journals and other places where you can be submitting work with these tools having been involved. And then, not to belabor a point, but we do have pretty clear evidence that people are doing things that are just really not great with these tools. So this is a French researcher who works with Retraction Watch, and he's actually programmed some tools to identify papers that are published. So these are literally papers that make it through peer review, editorial review, copy editing to the point of being published, that have tags from large language models still in them. So here he was tweeting literally the introduction of a paper where it was clear, this paper had made it all the way through to the point of literally getting published in a journal. And it was essentially output directly from a large language model like ChatGPT. This is a bad idea. So, it seems like who would literally do some of these things, but we have actual evidence of people doing these things. So don't do this. And then similarly, this is a figure from a paper that went viral maybe a year or 18 months ago. It went viral for a lot of reasons, not the least of which is the fact that they used generative AI to generate all of the scientific diagrams in their paper, despite the fact that the diagrams made no sense scientifically, and that they could not actually generate real descriptive words for the most part on the diagram. And yet this paper with these figures made it to the point of being published. So take these as warnings. There are people doing things that you don't want to do. And so don't do these things. Be responsible and ideally ethical with your use of these tools in your science. Okay, and now just to give a bit of an overview for today, there are a lot of different places that we could go in this talk. I am going to try to be broad in terms of giving people exposure to a lot of tools that within the data science lab we find useful. But there is some amount of prioritization. You know, and just this morning I was thinking of this food sort of analogy for it. We're going to start with dessert, the things that are like cool and fun, but probably not super applicable. Move on to things that are sort of helpful, kind of light food. And then I'm going to try and focus most of my time on the actual things that we use regularly. And then Josh is going to focus on probably the most interesting parts of this, although the most sophisticated. So from a food perspective, this is his part of this is where I would want the food critic to actually review. Okay, so starting off with the dessert pieces, these are things that are cool, but they're just not really super applicable to research unless you use some very narrow use cases. So one part of this is image generation. Image generation gets, talked about a lot, but it's still, from a science perspective, a pretty narrow use case. We can't really generate scientific diagrams or images, and it's still pretty hard to use these tools to do things like edit images. So, I've listed out some of the options here. A lot of the big large language models like, DALL-E and ChatGPT, Imagine, and Gemini, these are sort of whole image generators. That's sort of an example at the bottom. So you can type in things like, give me options for a text-focused data science lab logo, and it gives you back options of entire pictures. It's kind of hard to refine parts of this. And then there are some more specialized tools. So Adobe Firefly, Recraft are much more graphic designer focused tools where they're much more complex, but it allows you to do a lot more refinement and sophistication within the image itself, as opposed to simply scrapping a whole image and regenerating a whole image. And then there are some really interesting things that are more experimental. So for instance, Whisk is an example at the top. This comes in really handy when your daughter needs her favorite stuffed animal turned into a coffee drinking scientist cartoon character. So it has some very powerful applicability, but more narrow regards to science. And then there's been a lot of talk about video generation. That's still pretty early, but again, those types of tools are out there. And then more generally, I guess I should also say, Gen AI image analysis is an incredibly deep hole to go down. There are a million different models. There are lots of different interfaces and how they're implemented. It's a place where you can spend a lot of time. And so I'm just hitting the very highest level of this, given its kind of lack of applicability to a lot of research. But then similarly, just generally in these other types of things of like, what is cool and new in the Gen AI space, even if it's not potentially directly relevant to research, there are almost unlimited, other types of things that people are talking about and are taking up airtime. So Sesame.com is one that's come up recently. This is really focused on extremely human sounding voice generation, to the point that they've implemented a large language model that you can test, where rather than typing in your prompts, you actually converse with it, and it has a very real-time, potentially in-depth conversation on topics in an extremely natural sounding way. One of the ones I wanted to highlight was Hugging Face spaces. So we don't have time to really get into Hugging Face. If you're not familiar with Hugging Face, I would sort of say what GitHub is to software, Hugging Face is to artificial intelligence. So it is a sort of ecosystem, online repository where people develop and share, I mean, an unlimited, a huge variety of different tools, large language model and other types of artificial intelligence tools. But Spaces is really a part of Hugging Face where people that have developed these tools can then implement them essentially as web apps. And so, you know, there are 100 pages of these various tools that people have implemented across all of these different categories: image generation, video, text, language translation, speech. I mean, this is truly, again, these are maybe not the most robust. Many of these are, it's kind of like research software on GitHub. They can be experimental, but this is a place where you can find an almost unlimited variety of different things in the Gen AI space to explore and potentially work with. Okay, so moving on past dessert and now thinking about Gen AI tools and applications that are sometimes helpful. You know, it's nice to know that they exist. You want to have them when you need them. They're not things that I would say I certainly pick up or use every day. So one part is now the inclusion of Gen AI tools and just generally AI tools in meeting software. So specifically something like the Zoom AI Companion, which we probably have all been getting emailed about from UNC, or at least within the School of Medicine, that it's been enabled on our Zoom accounts. These are fairly useful tools within the meeting space. So I sort of break it down as there are during meeting functions and after meetings, and these cover a lot of the things that are sort of, you know, maybe the harder, you know, tedious work involved with meetings. So taking notes, generating summaries, answering questions in meetings, summarizing, all of these different types of things. So depending on your meeting load and your uses, some of these types of tools are really helpful. In addition to Zoom AI Companion, I know there are other people that use other tools. I think something you do have to be mindful of, particularly in some of our conversations in, say, at School of Medicine or other areas. So obviously the audio is going to some offsite server for processing, and that's a pretty serious consideration for areas that are talking about things that would be considered tier 2 or tier 3 data, right? So things that have PHI or sensitive conversations. I actually don't know exactly if we have formal policies on this aspect of using meeting tools in some of these types of conversations. I would think that we do somewhere, but I think at a minimum, we have to be aware of what is happening and the types of content we're talking about in these conversations when using these tools. So another sort of sometimes helpful limited use case, writing and presentations. So let me start with presentations, given that the video is going. So depending on how you use innovation or how you use presentations, how often, there are increasingly tools to essentially auto-generate full slide decks, which you can then just edit. So below is a demo video from Canva Magic Design. The way this tool essentially works is it's a web app. You can feed the prompt about 5 to maybe 10 different keywords that describe the presentation you're looking for. And then it generates a slide deck with a bunch of slides that it guesses would be useful to you, and then you can edit it as necessary. Again, there's something similar in PowerPoint, the designer option, which gives you a bunch of different options for your slides. After you put content in, it will give you a bunch of different visual, different options for rearranging it. Google Slides with Gemini is another option. I think mileage kind of varies on these. Sometimes the slides are great, sometimes they're, you know, not that great. But so again, depending on your sort of presentation load. These can be helpful. Writing and using large language models in science writing is pretty fraught. I would say the places that I have tried to restrict my use of them personally are things like editing existing text that I've generated for grammar, for diction, making rewrite suggestions for clarity, conciseness. And a really helpful thing that I use it for is after writing a manuscript or an abstract, if I need to say generate a lay abstract, large language models are pretty good at this. But this is obviously a pretty broad area, as people are sometimes trying to actually write sections of grants or write sections of manuscripts and use a lot of the verbatim text. So I would say they can be helpful, but as I've said before, tread carefully in this area and be judicious in how you use them. Okay, and so now I would say moving on to the portion of my content where we're getting more into topics that we use large language models for often or really often. So question and answer or sort of generalized search. So I would say personally, a variety of large language models have replaced the majority of my actual internet searching. I find that it is more effective and efficient to actually ask large language models my questions than to say search Google. For these purposes, I tend to default to what I think of as like sort of large scale, blue chip enterprise large language models, right? So ChatGPT, Gemini, Copilot, things that are really big and broad and usually like trained on the entire internet. That large scale training buys breadth. So there's usually good recognition that the model knows your knowledge exists and may or may not have much information on it relative to a small language model, like a small llama or Phi or Gemma. I'm at the point now where I don't know that there are so many differences between some of these large scale models. I sort of tell people, sort of explore and, what your personal preference is usually sufficient. I also, oftentimes people ask about like how good is paid versus unpaid. And my response is I don't know exactly because I have pretty much no paid accounts other than the Copilot that we get through UNC. I typically am just using completely free ChatGPT in an incognito window to ask questions. And maybe another piece that I have to talk about is on any of these models where the model lives on some corporate server far away and you're entering information into a prompt and sending your text to that server, I don't think you can consider that information you enter to be safe or private. I think there is a fair consideration or assumption that that information, anything that you feed that model, is probably saved. I think there is a reasonable expectation that you could be identified and linked, at a personal level or at least at an IP level to whatever information you're sending. And then I think with the current regulatory framework, I think you have to assume that anything you put in could and very likely would be used by these companies for recurring and future development. And so I think it also needs to be said, I think the expectation is we should never be putting any type of private or sensitive data into any of these models going out to third parties externally. So just as a sort of quick example on, how do some of these work? So here I am in free ChatGPT. I am not logged in. This is not a paid account. And so let's see, let's ask it about something research specific. That's sort of literature exploratory. And it's also interesting to see when you talk with models about literature, whether it hallucinates or not. So just off the top of my head, for the CCI, Charleston 87 is a real paper that's a seminal paper. JO92 is real, Quan 2005 is real, Charleston 1994, I think is real. Josh is telling me, yes, it is real, thank you. Sundararajan is real, Alex Hauser. Yeah, so I think all of these are, we actually got no hallucinations, but it's always interesting to do this with literature because these models will confidently give back a lot of information on literature, oftentimes to the point of inventing papers that look like exactly what you need and even attributing DOIs to them. So more than once, I've tried to ask about a topic and look for papers, and it will feed me the exact type of paper I'm looking for, only to realize that is a hallucination. And the DOI is maybe real, but points to a totally unrelated paper. So I think you do have to be somewhat careful using models on discussing literature. And we'll look at maybe some more literature specific options later. And then let's see, what else did I say? Oh, maybe another application that people are less mindful of is actually using large language models, not for the direct output that you're interested in, but for input to something else that saves time. So for instance, generate to create a so large language models are good at generating text. They've gotten much better in the past year at generating image and other types of things, but I would still say they're kind of optimal at generating text. And in fact, large language models that don't have other pieces like image generation models, I mean, it's still basically all they can generate is text. But so this is an example of ultimately I want a diagram, but I can get the large language model to give me all of the text that I would need to put into another application to essentially generate the example diagram I'm interested in. So this is a use case that I use actually kind of frequently to save time, right? Rather than thinking about the actual input, I can sort of feed the input need and get that and then simply input it into another application. And then similarly, something that I use semi-frequently that maybe people don't think about as much is synthetic data generation. This is really helpful, especially for things like natural language processing or sort of reprexes or reproducible examples. Oh no. It doesn't like that response. Well, you'll just have to take my word for it that ChatGPT is really good at generating synthetic data. Oh, another piece that I want to highlight in the area of question and answer and language model use is LM Arena, which is a pretty big site from kind of the large language model community. This has become a sort of major site where models are ranked against each other. And you can actually participate in the battles and the side-by-sides. Basically, these are places where you can ask questions and they'll blinded give you the results from two different models and you can rank which is better. But this is also where you can kind of test different specific models at the exact same time, right? So here you can do Grok versus, any of these 90 models. Let's get Claude Fuse on it. And so this is a way, sometimes I'll use models of different sizes to sort of get a sense for, maybe like what size model do I need to feel like I'm getting the amount of information I need, what's the sort of trade-off in depth and sophistication, how complete are models, all of these types of things. And it's convenient to be able to look at multiple model outputs at the same time. So another piece that I'll just highlight quickly is the leaderboard. So the leaderboard is where you can see essentially the real-time rankings of models, and this gives a sense of, amongst a fairly large community of users, which models in a variety of domains are getting ranked as being the highest performing. So these are just text large language models, but then you can also do vision models, text to image. There are a variety of different model types you can look at there. But so this is a useful type of tool. There are other tools that allow you to do this too, looking at multiple model outputs at the same time, but LM Arena is a pretty common one now. And then I wanted to highlight search and deep research versus just model output. So what we were just looking at, I would say, is standard model output. So that's really the model. These large language models are trained and you're asking it questions, and it's really going from the data set that it's training on without including additional information. But increasingly, there are more enhanced functionalities. So ChatGPT has a search functionality. So in addition to the model output, it will do some amount of actual internet searching to supplement. And then deep search is even a new level. I think maybe. So Perplexity is an example of this. For deep research, oftentimes you either need an account or need to be logged in. Deep research, though, will usually take model output and combine it with some amount of sort of agentic functionality where it will do a pretty significant amount of deep level searching to append a full report of information together for you. These deep research functionalities will often take a couple of minutes to compile, and usually the software will tell you what's happening. So it's essentially processing in model and then going out and reading a bunch of resources, and within a couple of minutes, it will compile together a full report. So there you can see there's some amount of reasoning also put into this as it processes and then continually updates and refines the search and then searches more. And so this is another functionality that I don't use it as often as general model sort of question and answer. But for instance, like, this I've used at the beginning of, say, literature work of a new topic, where actually this is an example of something that I've used on a research project, where we just needed to get quickly, rather than spending a couple of hours going through literature, can we jumpstart it with, pull together the list of major independent risk factors for bladder cancer. Compiling. There we go. So now it's compiled the report. Goes on and on. So deep research across a variety of tools has been something I've used. And then I very quickly just want to look at this example of Manos. So this is a new agentic tool that I think has been getting a lot of buzz recently. I think it's still only by invite to join it, but I can show one of their kind of canned demos. This is even another level of independent work. So this is an example of a demo that the company behind this actually gives, where a person had 20 resumes and they basically just asked the model to read all the resumes, compile the 20 separate PDF resumes into one spreadsheet, and additionally rank all of the candidates based on some criteria related to the text in the PDFs themselves. And so it has access to its own separate processing system. And so you can see it's calling Unix at various points to do some of the processing, and then it's calling Python at various points to do some of the processing. And then ultimately, as it's, let's see, it's on 13.14, so it's almost done. When it gets through the end of this, it's going to automatically open up a new spreadsheet that not only has the structured data from the PDF resumes, but then it also has the subjective rankings based on all of the criteria that it evaluated as important for the candidates. Okay, so here we go. This is the completion. You can see all of the candidates are in this spreadsheet. All of their text responses have been parsed into essentially structured fields. And then create some summaries. It identifies highlights. So this is fairly sophisticated, but then additionally, it offers these scores and its ranking of what it defines as expertise level. So I would anticipate if we gave a version of this talk a year from now, we're probably going to be talking about tools that are doing this even beyond what we're looking at today. Oh, okay. So I don't want to go very deep into this, but the other question is, everything we've talked about so far is essentially proprietary commercial tools for the most part. Like some company out there has a tool, it's on their server. What if you wanted to do this locally, or what if you needed to do this locally? There are a lot of solutions to this. They got technical in a pretty big hurry. Probably the biggest is Ollama. So right here I have Ollama running in PowerShell. So this gets complicated because you both need the hardware to run the models quickly, but also, Ollama, you're working in PowerShell. So it's reading, and there you go. Increasingly, we're looking at things like Misty. So Misty is actually a GUI front end for Ollama. So you can have Ollama running essentially in the background, but you get more of a ChatGPT style interface to it. And then similarly, anything LLM is a pretty nice tool for running localized models, again, with this sort of more GUI front end. But also, I mean, you can see the speed at which the Llama model in Ollama responded, but that's also because that's running on a really big VM. This is a 48 core by 96 gigs of RAM machine. So in addition to just the technical pieces of running these, there are not insignificant kind of hardware sides of this, so just having enough power to run the models. Okay. And so then moving on to literature exploration. Literature exploration, I think, is a really, really major use area. A lot of these tools, I would say, they're not necessarily strictly what I would call artificial intelligence. A lot of them are more focused on machine learning and things like facilitating bibliographics. But I increasingly use these because I find them really helpful. And so let me just give an example here. This is Litmaps. Essentially, I find many of these tools, Research Rabbit, Litmaps, they're pretty similar. So let's see, here's this huge quad. This is a Charlson comorbidity. Using that as my key paper, what it's doing now is running bibliographics or bibliometrics on this relative to other papers. It's going to generate a network graph relating my source paper to all of these linked papers. And then it starts to give me, ways to update it. I can add more to the search to refine this and continue to find more papers. And then additionally, you can start running some different metrics on all of these. And so for literature exploration, I've been using a lot of these types of tools, and I do find them pretty useful. Literature summarization, I think, is a separate discrete area. This is where I feel like this is, to me, one of the strongest use cases currently for artificial intelligence in science. I would say there are many different versions of these that function similarly. You know, they're tools that basically say, feed us a paper or a PDF, and we will summarize it or do a variety of different things. Despite there being so many, I find that Google Notebook LM is basically still the most powerful. Let's see. Okay, so here I am. I'm logged into Google in this browser, so I can get into my Notebook LM. Here is a workspace that I've created. I've essentially just loaded a paper from the data science lab looking at variations in networked OMOP data. But so this has taken the PDF. It's telling me that there's one source in this workspace. It gives me a brief summary, but then basically it gives me all of these other functionalities. So I can generate a study guide based off of this source. If I had multiple different sources or papers uploaded to this, it could give me a study guide based off of all of these different sources, right? So it's highlight the major, what it considers the major portions of this paper. It gives me a study guide and an answer key. And then similar pieces, right? So FAQs, briefing doc. And one of the other pretty amazing things is, in addition to this summarization by text, it also gives summarization by audio, where it will generate essentially a podcast of your paper in lay language. And let me see. Yeah, so I mean, this is literally just generating a casual podcast based off of the text, as though you had a speaker and an interviewer going over the topics of your paper. And I am willing to admit that I essentially use Notebook LM for handling like a large amount of my literature reading needs at this point. Like, I typically, before I make the commitment of fully reading a paper start to finish, I will usually summarize it here. I might even listen to the audio overview. And then on areas that I have more specific questions or need more detail, I'll go back and review more closely. But this is, I can't really overstate how useful I have found this, particularly when you have like a stack of papers that you are trying to get through. So I've talked about summarization by text, summarization by audio very quickly. I also want to point out Google Illuminate is a separate summarization by audio tool where it actually lets you tweak that audio podcast. You can have a more formal interview, a more casual, where the speakers and the way they treat the topics is updated. And then the last thing on literature summarization that I wanted to point out are tools like Elicit and Consensus. These are tools that attempt to really more take sort of a high level question, assess a whole body of research, and then try and give some sort of research-based answer. So here, we're just going to ask their example question of, are statins effective in the elderly? And now it's assessing its body of papers that it has available to it. And it gives you this consensus meter. So based off of the relevant papers it reviews, it's attempting to infer whether it's a yes, a no, or a maybe. And it gives you this visual answer. But then additionally, it gives you this sort of report breakdown. And I guess I should say, these tools, like Elicit and Consensus, I find that the value has varied widely by the questions that you ask. And often those do require accounts or paid subscriptions to get more than a really small number of uses. Okay, and then I think this is my last portion, but coding. I would say at this point, large language model or AI coding assistants are essentially, borderline required in many disciplines. I mean, I would say we use them frequently, maybe in almost every coding environment we have in the data science lab. The optimal is if it's integrated into your IDE. So, we use Databricks often. Databricks has an integrated IDE. But then other tools, so, there are things like GitHub Copilot that can be integrated. Cursor is really, really popular and commonly used across software engineering. So that's what this GIF is an example of. And Cursor, where you can see someone has their code on the left. They've asked a question about how to improve it. The model recommends, and all they have to do is hit accept, and it pushes those changes over into their production code. But then there are also some local options. So within Python, Jupyter AI is something that we've looked at. In R, there's Elmer, although that's very, very limited in the functionality. But these are, I mean, I called these transformational a year ago. I mean, I would say that these are essentially required or close to required at this point. And I think a year from now, we'll be even further down that path. And with that, I'm going to step away and give Josh time to go over his portion.
Can you enable chat while you transition?
I went.
Enable chat while you transition.
Yes.
From here. This is. On this screen.
Pull it up, yeah. And then the little 3 dots at the bottom, right?
Attendees can chat with.
Everyone and then panelists.
Yeah, set both to everyone.
Set photos.
Yeah.
Perfect.
Thank you.
Okay, we'll do that. I've got maybe about 10 minutes of stuff, and then we'll leave time for some questions. So I'm going to talk a bit about a project that I've been working on for the past couple months with a couple other people in the data science lab, Kara and Nathan. And Peter's actually done sort of a good introduction to this. It's about the Charleston Comorbidity Index. And basically the point of starting off here is that there's a lot of different versions of the Charleston Comorbidity Index. This is a graphic from Research Rabbit. I think Peter alluded to it, but didn't show it. So this is in green. These are what we've identified are considering major versions. And I think I'm just showing just for the sake of illustration here, about 50 different papers that all reference some combination of all of these. Additionally, you can look sort of even like at a broader sense, where really, if you look over the past 13 years, there's over 40,000 articles that we can find in PubMed Central that talk about the Charleston Comorbidity Index in some form or fashion. So that's led us to ask 2 questions. Well, ask and then answer. Question number 1 is, which of these versions is actually implemented most frequently? Then question number 2 is, how often is it ambiguous or missing which version is actually? So for a single paper, this is pretty easy. So this is an example of a paper that was published last year by some researchers here from UNC in the Department of Medicine. In this paper, this is one of the 40,000 papers in our data set here. They calculate the Charleston Index. You can see, so it's about 9 pages long. I forget, it's like 4,000 to 5,000 words. There's lots of information in here that's not actually about Charleston. And so if I'm taking this paper, I'm going to go through it. I'm probably going to sort or skim it, look roughly paragraph by paragraph until I find something like this. So this is one of the paragraphs from the actual text of the paper, and I've highlighted here, and it tells us a patient's overall comorbidity burden was assessed as the Charleston Comorbidity Index within a reference to Charleston 1987. So this is easy to do for a single paper. Doing it for 40,000 papers is prohibitive, both in terms of time and in terms of cost. I think even if you're paying an undergraduate minimum wage. And so I think this is a great use of LLMs because they're designed for speed. And we're going through, and I'm going to show you in a second what this looks like, but we're asking a very sequential set of questions. And we're trying to extract very specific information. So the model that we're using for this is Llama. It's Llama 3.3 if you're particularly interested. And so the model, or sort of like the data flow that we have built here, looks like this. So we take these papers, we sort of pick out the paragraphs that have references to Charleston that we think are going to tell us the information that we want, and then we're going to ask this LLM a series of questions. So the first question is, does this actually contain data on what we want? If it does, we're going to keep going, and we're going to say, does this contain more than one reference to Charleston, or does it not? Because those are two separate cases where it becomes easier or harder to actually sort of extract the information that we want. So if the answer to that second question is no, then we're going to directly ask it for the data that we want, and we're going to allow negative responses. If we go to yes, we're going to ask it for the references, and then we're going to have it question itself. We're going to say, are you sure that you're correct, right? Sometimes you might give us incorrect information. And so one of the keys, I think, about having this perform successfully, and we'll show you some like actual results here in a moment, is like there's a whole bunch of off-ramps here where we're not telling the LLM that this paper has relevant information, but we want it to actually extract that information based on only what's in the text. And so we're going to ask it if it contains data. We're going to tell it along the way that, okay, like what is the reference that is used here for Charleston? The answer might be none, and if it's none, I want you to actually say none. And then we're gonna, and in some cases, we're gonna actually sort of question and ask it sort of the same question again with slightly different phrasing. So here's I'll give you two examples of what sort of some of our prompts look like. So we start off by giving it some context. We're telling it, okay, you're a literature review assistant. Here's what you're going to look at, right? This text might include information that we want, it might not. And then we're going to ask it very clearly, answer yes or no. Does the following text reference which paper or weights was used to calculate Charleston comorbidity index? One of the things we do here is we always tell it how we want it to answer. So we say answer yes or no only. We do that in part because that makes all the downstream analysis a lot more easy if we can sort of anticipate what our data is going to be structured like. Going back to sort of this case where we have more than one reference, this is really the case where we spent a lot of time doing prompt engineering, thinking about how do we actually extract exactly what we want here. And so this is a good example of what we've settled on when what seems to be working really well is doing what's called few-shot learning. And so we sort of give it some context for that. There's going to be multiple papers in here, but not all of them might actually be used to actually calculate Charleston. And then we give it some examples. So right here's an example where there are two references. Both of those are actually used to calculate Charleston. Here's an example where there's two references, but only one of those is actually used to calculate Charleston. And I think we give it another like 2 or 3 examples to basically provide sort of like the whole breadth of data that it might encounter as it goes into sort of this process of extracting from these papers that have multiple references in them. And so it turns out that actually sending text to an LLM in Python is actually relatively straightforward. So this is a function that we're actually using. So the question, that is just the text that we're feeding to it. So that includes the question as well as the paragraph from the paper that we're interested in. We set some parameters. These have all been set in a way to try to reduce hallucinations as much as possible. And then we get our answer out at the end. And so as just sort of a preview of what these answers look like, this is a set of, well, this is 4 papers out of these 40,000 that we're looking at. And so you can see we return the PubMed central ID. And so this helps us with validation so that we can go and look up some of these papers and see for ourselves whether or not these responses are actually reasonable. You can see a lot of papers just have a single paragraph where they talk about the Charleston. Some papers have 2, and so we have to deal with those in a slightly different way as well. And then you can see here, these are questions 1 through 5 is what we are currently doing. The sort of the brief version of these is down below. And so we ran, just to wrap up this part, we ran a test a couple weeks ago now, comparing amongst the three of us, if we took about 80 papers, like how much like agreement was there between sort of humans like manually going through these papers and agreeing with each other, and sort of and extracting references. And we were about, I believe the number was about 92% in agreement with each other. And then I took the LLM and I said, look at these same set of papers, give me references for all of these, and then I'm going to compare these to how, like what we actually thought the references were. And those references were about 94% accurate. I compared it to myself, with myself. And so that was encouraging to see that the overall sort of the model seems to be working, that we're not extracting a whole bunch of sort of miscellaneous or incorrect information, but sort of gives us encouragement that we're on the right track. And I think relatively soon are going to sort of apply this model to all 40,000. So that's an example of how we're actually using LLMs in research in TDSl nowadays. I think that's it for what we have today. So I think we have some time for questions, and I don't know if Peter wants to come back up. And if you're interested in previous seminar recordings, you can go to that website to get. Let's see. So I guess I'll just go through the ones in the chat. So let's see. My team uses Microsoft Teams for meetings, not Zoom. Well, when will UNC allow an AI assistant to take notes during Teams meetings? Do you have thoughts about that? I do not know the answer.
Yeah, I don't know anything about MS Teams specifically. And I would imagine that probably falls somewhat under the purview of like UNC use. Like they might have guidelines about the different systems that tools can get added onto. I mean, I would think just from a raw usage standpoint, I'm sure there's some sort of third-party tool that can be used there. But since a lot of our tools are within UNC are already Microsoft based in terms of being in like the Microsoft Copilot ecosystem, I don't know if there is some sort of inclusion between those two. I will say, there are different integration levels of Copilot. So for instance, like we have access to, I think, the more enterprise version of the tool, but not the version that's actually integrated into Office 365. So I don't know if, again, there's some sort of other, subscription model where you have to sort of buy access to MS Teams or those types of things. And there's a question about LLM tools available within Epic. So I would say that falls 100% under the purview of the healthcare system. They really run their AI utilization, I would say, independently, largely of UNC, the campus. And I do know that as the health ecosystem makes a pretty big push to go to cloud integration for a lot of their IT infrastructure, my sense is that a lot of that has been to integrate AI, but the only details I have on that are essentially what's available from the press releases. So I think the first piece of that was really moving to a bridge for, documentation support and transcription support, but I don't really know much other than that. And let's see, any other questions? So question on slide decks. So the slides will be available. What we typically do is release a recording of the seminar. And so the slides would be available in the recording of the seminar. Let's see. Health Science Library regularly offers sessions by invite on Gen AI tools for research, including things that we talked about, like Elicit Consensus Research Rabbit. Any questions from in the room? Yeah.
Yeah, I guess just with regard to potentially using these tools on like HIPAA protected data or healthcare data. You mentioned the security component, or like any data you plug into an LLM like will be used to train their models. I guess I'm interested as well in the issue of algorithmic bias, and the idea that like since you don't necessarily know which inputs are being used to generate the output, like whether like factors like demographics or other elements of a patient or any other source data, like even if you're taking in resumes, like whether those play a role in the output that the AI creates.
Yeah, I think it's challenging. So the question is really about not just sort of the use cases that could involve like bringing these types of models in close contact with sensitive data, but also the potential for things like algorithmic bias or other types of biases inherent in the models themselves. I mean, I think this is, to me, a pretty active area of thought on these models. I think the initial focus very early on, starting a couple of years ago, was sort of on raw functionality and demonstrating like that certain things were possible. And now we've spent more time later on thinking about like, how does that happen? Because within these models, it's fairly opaque in terms of how you're getting to the results that are actually coming out. And so how does one sort of interrogate the models themselves and the parameter tunings and weights to do that short of, iterative fine tuning of models based on different data sets. But yeah, I mean, I wish I had a better answer other than that. I do think it's still challenging and a pretty active area of research. And this is something that I think we'll probably continue to be talking about for a long time. But I think that, from the bigger picture, that is certainly a real concern to think about understanding the tools and the implications before we sort of implement them into a wide variety of uses, especially operational uses. And I think this is why, for the most part, you think pretty hesitantly about, let's just automatically say, like, put them directly into patient care workflows or put them directly into, I don't know, like Social Security benefit payment workflows or like other places that have very patient-facing or person-facing implications. All right, we are at time. Thank you, everyone, for coming. I will give a little bit of heads up. So next month, our April seminar will be given by Sean O'Neill, faculty from genetics, member of the TDSl. He'll be talking about actually evaluation and scoring methodologies and interpretation of those for large language models and other types of AI models. And so within the next couple of weeks, we'll be sending an invite and some information out about that. But if you're interested in this topic, feel free to come back and go even more in depth on this topic. All right, thank you, everyone.